93. And this time we're looking at, if we know the number of moles of a compound, then can we figure out the number of moles of each element present in that compound also? So this is a very similar process to page 92, except now we're working with the idea of mole. So 1 mole of a compound equates to each of the elements present in it. So we simply look at the elements subscript. So take a look at this. If I have 1 mole of the compound and I want to determine the number of moles of the atoms or the elements present, this is how I would solve it. So in this compound, I have calcium, I have phosphorus, and I have oxygen. Those are the 3 different elements found in this compound, calcium phosphate. So when I look at this, to build 1 mole of this compound, it requires 3 moles of calcium. It requires 2 moles of phosphorus. And it would require 8 moles of oxygen. So I know 3 moles of calcium, 2 moles of phosphorus, 8 moles of the oxygen. So I know the number of moles of each individual element, and then if I add those up, 8 plus 2 is 10, plus another 3. So there's a total of 13 moles of atoms present in this 1 mole of calcium phosphate. So here we go, looking at a 2-step process. Here's our first example. Determine how many moles of atoms are present in 2.5 moles of CCl4, carbon tetrachloride. Well, if you have 1 mole of carbon tetrachloride, then that means that you would have 1 mole of carbon, 4 moles of chlorine, so a total of 5 moles of the atoms or the elements present. There's its relationship. So in this question, instead of having just 1 mole of that compound, I actually have 2.5 moles. So if I have 2.5 moles of carbon tetrachloride, and I want to convert it to moles of the atoms, I want to be able to cross off moles of CCl4. So what I put here is the relationship that we figured out that's in up above. For every 1 mole of the carbon tetrachloride, there are 5 moles of atoms to make present. So now we do the math with the numbers. So we have 2.5 times 5, which will get us to 13. So whatever we do with the numbers, we now need to do with the units, right? So take a look at this. I have mole times mole divided by mole. So I have a mole upstairs and a mole downstairs. So this mole right here is my remaining unit. Now I need to do it with the descriptors. What does that quantity and unit belong to? Well, I have CCl4 times atoms divided by CCl4. So I'm allowed to get rid of the CCl4s because one's in the numerator, the other one's in the denominator, and it belongs to the atom. So 13 moles of atoms would be my final answer. So let's take a look at one more example here. So the second we do says, determine how many moles of atoms of oxygen are present in 4.5 moles of the compound calcium hydroxide. Well, in order to make or build 1 mole of calcium hydroxide, that means you have to have 2 moles of oxygen atoms. So there's our relationship right there. So now, but in the lab, instead of having just 1 mole of calcium hydroxide, I have 4.5. So if I have 4.5 moles of calcium hydroxide, then I can convert it using my relationship written in green to moles of oxygen atoms. So my relationship is what I determined up here in the green. For every 1 mole of the compound calcium hydroxide, it means that I have 2 moles of oxygen atoms present. So I do the math in my calculator of 4.5 times 2, which calculates out to be 9. I have to do the same math with the units, mole times mole divided by mole. So I have this mole upstairs, this mole downstairs. Allowed to cross them off, they reduce to 1. I'm left with 9 mole. And now I have to do it with the identity. Calcium hydroxide times oxygen atom divided by calcium hydroxide. Since I see calcium hydroxide in a numerator and denominator, I'm allowed to get rid of it. And the 9 moles belongs to oxygen atoms. So you try the 2 you-dos, 1 and 2, here at the bottom of the page. Check your answers with the teacher.